Good afternoon. Welcome back to the channel. This video is not financial advice. I'm not a financial advisor. Do your own research, make your own decisions. Okay, guys, welcome back. So in this video, I'm going to be drawing parallels between how the human brain works and how quantum computers work. And I'm going to be using a human equivalent simulation and or just a thought experiment to make this case. So create a simulation to gauge the probability of different outcomes over the next 10 to 15 years as it relates to the advancement of technology, the web, and AI. And for most serious long-term investors, to some degree, you likely already went through this process. When you're looking at the next 5, 10 years and you're trying to position yourself for the most optimal tech investments, you're going through some type of process like this. How thorough it is would vary person to person. But just be thinking with that as we go throughout the rest of this video. I need to go over a few things about traditional computing and binary logic really quick, but this video will be general and abstract because I don't want to confuse people with a bunch of technical terminology, and I'm just trying to draw parallels between how both systems work in this video specifically. In further videos in the future, we can discuss other topics. Binary describes a numbering scheme in which there are only two possible values for each digit, 0 or 1. So only two possible values, and is the basis for all binary code used in computing systems. All right? Now, outside of quantum computers, all other types of computing systems run on binary logic. It's always been that way. So when you're thinking about binary logic, think if X, then Y. All right? And don't think about computing system. Think about people and the way they process information and the way they react to certain incoming data. So for this whole entire situation with ICP, big picture, the future of Web3, where is all of this going? Where are we going to be in 10 years? So on and so forth. How often do you see something happens, X happens, big price crash? It could be chaos in the ecosystem. It could just be some new AI app builder comes out, and then look at the immediate knee-jerk reaction, the black and white reaction that happens with so many people. Big price crash equals it's over. Chaos in the ecosystem equals ICP is finished. Some new AI app builder comes out, Caffeine AI doesn't matter. Nobody's talking about the importance of things being on chain, so on chain doesn't matter. Think about the black and white logic or lack of logic that's used so often when people are trying to assess this whole situation. Now, what is the error they're making? The error they're making is they're only looking at one variable, one incoming data point, one little thing in an equation that is the biggest, broadest type of an equation that you could ever try to analyze. All right? So, using binary logic with simplistic scenarios makes sense a lot of times. Let's say that you're at a stoplight and the light turns green. That means go. Let's say that you go outside in the rain without an umbrella. That means you're going to get wet. So, but using this type of logic while trying to analyze highly complex scenarios that have tons of variables to consider does not give you a clear outlook to the most probable outcomes. The quantum world is all about probability because you've ignored the large majority of variables to consider. Okay? So classical computation and bits has to be either a 0 or 1. Now qubits could be 0 or 1 or anywhere in between. They exist in a position called superposition, which is a fundamental concept in quantum mechanics describing the condition in which a quantum system can exist in multiple states or configurations simultaneously. So if we're just comparing traditional computing with binary logic and quantum computing is a more flexible, dynamic form of computation that is better designed for certain types of computation. All right? Okay. So back to the original simulation or scenario. Create a simulation to gauge the probability of different outcomes over the next 10 to 15 years as it relates to the advancement of technology, AI, and the web. Where would you start? You would find the most relevant and important variables, and you would look at their state at any given point in time. So you would look at their state in a static environment, but you would continuously be evaluating that state as new data comes in and as things change, and we're going to talk about this. Then you would track that over time in parallel with all of these other variables. So let's just give some examples of what common sense variables might be in a situation like this. The global economy would be a variable, right? Now, that could be broken up into different categories. So number one could really be 10 different categories in its own. But I'm just doing this as a general example. The financial system could be a variable, and they all have their own state Okay. Now let's break the financial system down into a couple different categories. You have infrastructure and technology with the financial system, all right, and the state that it is in. Is it all using up-to-date tech? Is everything running very efficiently? That all speaks to its state at any given point in time. And then you have global liquidity and the state of global liquidity and the trend, the broader trends of global liquidity. You have AI. AI can be broken up into so many different categories. Advancement, trends, the risks associated with AI. Today, the state of AI and AI deployment is different than it was 2 years ago. They're experiencing significantly more problems deploying AI into the enterprise world now that it's had a couple years to kind of get out there into the marketplace. And so the states are changing day to day, week to week, year over year. Problems, opportunities, blockchain, the state of the blockchain industry and or the state of any one given network, regulation and compliance, not just with blockchain in a general sense, but also with AI, with the web standards, W3C, potentially new regulatory and compliance standards around data protection. Starting to see a lot of stuff about that. Think about passkey, right? This is all speaking to the state of these different variables. Global tech trends, big tech products and services, cybercrime. Again, this can be broken down in different categories. Enterprise, the state of the enterprise space at any given point in time. The web itself, the subcategories, the problems with the web, the state of those, the web as it relates to AI, the web as it relates to stolen IP, and then ICP. And you could break ICP into many different subcategories as well. The problems that it solves, the positioning, all of these things, where it's at in its life cycle, that all speaks to the state of ICP at any given point in time. So let's say all of these blue dots are variables that we just went over, okay? And they exist in their own individual state at any given point in time, but that's changing day after day, week after week. New data is coming in with any one given variable, and then you have to plug that data into that variable to see how it impacts the broader equation. But all of these things are dynamically changing week after week. Okay? Now, one variable may have some perceivably bad data coming in. All right? Meanwhile, three other more important variables have overwhelmingly positive data coming in. So let's just say for one of these variables, I didn't put price up here, but let's just add price up here. So that would be one variable, right? And so let's say price goes down and somebody looks at price is going down, and they can't see anything else outside of that. They go right back to using binary logic. Price is down, everything is bad, this isn't going to work out, right? It's a equals B, if X, then Y. That's the type of logic that they're using, right? So one variable, like price, may have some perceivably bad data coming in. But if three or more than that, other variables have very positive data coming in, you have to factor it all into the equation. You have to factor all of these things in and analyze them in parallel over time as they're changing to see if the changes in the new data are changing the overall probability of the most likely outcomes. So price would be the perceivably bad data coming in. Meanwhile, you could have numerous different technical upgrades happening at the network level that's going to enable more and more functionality with AI. You could have institutional partnerships. You could have cybercrime potentially being deemed a national security threat. See, cybercrime is one of our variables. Cybercrime being deemed a national security threat or getting significantly worse changes the overall equation, makes certain probabilities more likely than others. AI deployment problems, web standards, all of these other things. But if you're only looking at one variable, if you're only looking at this one specific variable and you're isolating it and you're not even seeing all these other blue dots, you're not seeing all of these other variables positively changing that just further suggest that we're moving to a Web3 with ICP at the center because you're just looking at that one dot and you don't have a comprehensive overview of the entire picture because you're using binary logic and you're just isolating one thing and saying this is happening, so this is bad. And the next thing you know, it turns into the biggest problem on Earth. And then a week or so later, things kind of rebound and everything's fine, and you just lost perspective for that period of time because you weren't using sound logic. You weren't using a system or a process or a framework that was going to give you a complete picture of the situation. You were looking at one data point. So the state of regulatory compliance and web standards variable, that's trending to new compliance standards around protecting data for anybody who hasn't been paying attention to that. And the World Wide Web Consortium is recommending verifiable credentials. These are all different variables that we listed off, different variables that are in the broader equation, and their state is changing, but it's changing in a way that further suggests we're moving to a Web3 with ICP at the center, that's the most probable outcome. This is all about probability. We can't predict the future, but you're trying to just look at the most probable outcomes based on the most comprehensive analysis that you can do. The state of cybercrime variable and stolen credentials is becoming a bigger and bigger problem and one of the main attack vectors. So that would be a positive catalyst. That would be a state changing that further supports the original thesis. The state of ICP, solutions are being created to solve this problem. All these are all different things that you're analyzing in parallel, but they're all changing in a favorable way simultaneously. ICP is also a member of the World Wide Web Consortium. The state of blockchain adoption with institutions, more specifically with ICP. ICP partnered with the United Nations for Universal Trusted Credentials. That would be another thing that's happening that is very optimistic about the future of all this tech, especially ICP. And then passkey, real ID, CAPTCHA, so on and so forth. The point that I make is that to do a human equivalent simulation of the next 10 to 15 years, and you wouldn't be able to do it to say this is definitely going to happen 100%, no questions asked. You're just trying to gauge the most probable outcomes based on the most comprehensive assessment that you can do, that you're continually running in parallel because things are changing, and you have to plug that new data that you're getting into the broader equation to see how it changes the broader equation and potentially, or whether or not it does change the probability of the most likely outcomes. But again, if you're isolating one data point, if you're isolating one thing, if you're only looking in a very narrow way, you'll lose sight of all of this. And you'll turn this, something that's probably not that big of a problem, into a giant problem because you never had the right framework to begin with. You were never assessing all the most important variables that you would need to assess to have a clear outlook on the situation. This is the biggest, broadest analysis you would ever have to do. We're talking about the future of the web. There are so many moving parts with this. It's absolutely insane. So the best that you can do is look at all the most important and relevant variables and keep track of those over time in parallel with each other. Notice how things are changing, see whether things are changing for the good or for the bad, and then just update your equation and update your overall outlook and probability. As opposed to just looking at something and saying, oh, wait, price is down. Oh, that's bad. Things aren't going to work. Oh, wait, Web 2 launched some AI app builder. Oh, okay, that means caffeine isn't going to work and doesn't matter. That's old world binary logic trying to oversimplify the most complex situation ever in world history, which is what we're living in right now. We're talking about transitioning into the exponential age. We're talking about potentially migrating the entire web from Web 2 to Web 3, all as they just now rolled out artificial intelligence. There's so many moving parts to this. It's absolutely insane. So if you were going to try to create a human simulation to gauge the probability of outcomes over the next 10 to 15 years as it relates to the advancement of technology, the web and AI, you would have to factor in tons of different variables. All the most important variables you could consider, you would have to look at all of them. And then you'd have to keep track of their state over time as things are changing for the good or for the bad. Now, the real crazy part about all of this, I just went over my entire mental process and the framework that I use to analyze this situation. And I've been using this in a general sense, this mental model or this analysis process in my mind over the last few years to draw the most probable outcomes for the next 5 to 10 years. I'm taking you through my thought process with this entire video. But think about how similarly the human brain works with what I just described, right, to quantum computers. Now, The really, really crazy part about this is that the fact that, in my opinion, there are many ways in which the human brain mimics quantum computers and or vice versa. That is supposed to be 100% coincidence. Quantum computers and quantum computing were not created by trying to reverse engineer the human mind or the human brain. So it's supposed to be coincidental that the human brain and quantum computers work in very similar ways. That's all I have for this video. Thank you everyone for tuning in today. Hope you enjoyed the video. Let me know if you have any thoughts, and I may or may not do additional videos in the future. I will do additional videos in the future about this topic. I'm just not sure when and what topics we're going to be covering. But I hope that helps. Let me know your thoughts. Take care. Have a good day. I'll see you in the next video.